Hello everyone, welcome to Roots of Unity. My name is Marzukh and today we're going to start functions. So what are functions? They're basically methods to process the input and convert it to the output. However, there are limitations of the input and output though, as in it may be said that the input values can be any number from this particular set of numbers or the output may not exceed these values, etc. This restricted set of values for the input is called the domain, and for the output it's called the range. So we can see that the function connects the input and the output, thus relating them. Hence, a function is called a relation. There are many types of relations, but not all relations are functions. Let's see some examples. Let me just clear this up. Whoops. These are spoilers, I guess. Alright. These are all relations, but not all of these are functions. Relation is a function when every value of x gives one unique value of y. Hence, a one-to-one relation is a function and a many-to-one relation is also a function. But a one-to-many and a one-to-none are not functions. Let's use diagrams to clear out the concept more. So we can see in a one-to-one function in the y equals x plus curve 2, one value of x gives one value of y, one unique value of y. So there is a one unique value of y for every value of x. In a many-to-one function, two values of x gives one value of y as seen as in this equation. But there is one unique value of y for each unique value of x. But in a one-to-many, we can see that one value of x gives two values of y. So the unique property is lost. And in a one-to-none relation, we can see that there exists no unique values of y for these particular values of x. Hence, these two are not functions. Alright, let's explore another type of function called the inverse function. Alright, we know that a function takes in the input and then produces the output by processing it, right? An inverse function does the opposite. It literally does the inverse. That is, if it takes the input, it takes the output of the original function as its input and then it produces the input of the original function as its output. I'm using orange color to denote the inverse function. Okay, let's do some math to clear out all the confusions. So this is the diagram of the equation y equals to 2x plus 3, the function y equals to 2x plus 3. Let's set the domain as x belongs to R, which means that x is any real number, positive infinity to negative infinity. Now let's find out the inverse function. Let's denote y equals to 2x plus 3, and to find out the inverse function, we do the following. We reverse the input and the output. We make y the input of the equation. So we do that by making x the subject of the equation. Twice x equals to y minus 3, and therefore x equals to y minus 3 by 2. So the inverse function is x minus 3 by 2. I'm replacing y by x because I told you before that y is an arbitrary variable, right? So what's the domain of the inverse function? To know that, let's first look at here. We told that the output becomes the input of the inverse function, right? So the range of the original function becomes the domain of the inverse function. So the domain of the original function x belongs to R. So the range of the original function is f of x belongs to R, and hence the domain of the inverse function is x belongs to R. Now let's plug in some values to see some immediate results. Let's take x equals to 1 and x equals to minus 2. For x equals to 1, y comes 5 and y comes minus 1 for x equals to minus 2. So these are the values which will be plugged in the original function here. And now I told you that the inverse function, everything is switched, right? So the output is the input of the inverse function, right? So we're going to plug in the y values as the x values in the inverse function. Let's do this. x equals to 5, and x equals to minus 1. If you plug these values here, we can see that the y values for x equals to 5 comes 1, and the y value for x equals to minus 1 comes minus 2. So you see that these two are switched. In fact, if you draw these points like infinitely, plotting every point of the function, we can see that this curve, this function, this is the inverse function, and this is actually the reflection of the original function on the line y equals to x. See how the x and y got switched out? It's happened because it's reflected on the line y equals to x. In fact, it's a general rule. The inverse function is a reflection of the original function on the line y equals to x, and this is due to its inverse function's property. Now let's see another example. This is the y equals to x square curve, and its reflection is the y equals to root x curve. The one thing to clear is that an inverse function only exists for a one-to-one function only. Now why is this so? Because when a one-to-one function is reflected on the line y equals to x, a one-to-one inverse function is produced. However, when a many-to-one function is reflected on the line y equals to x, we can see that a one-to-many relation is produced. And a one-to-many relation is not a function. So this is invalid. So this cannot be the inverse function. We have to restrict the domain of the original function so that this becomes a one-to-one function only. We can do this by, let's say, determining x greater than 0 as a domain for which this becomes a one-to-one function. All right, let me just erase that. So if I draw this, where this is a one-to-one function, and this is also the following inverse function. Now this is absolutely valid. In fact, the other statement is true, as in for it exists for the negative domain as well. Let me just draw this. So this dotted line represents the inverse function and the original function for the negative domain. So that's all for today, folks. We covered the basics of function, inverse functions, what are relations, and that's all for today. In the next video, we're going to cover composite functions. Until then, my name is Marzukh, and this was Functions. See you later.